minimum. Thank you. So good. Okay. The fancy definition. The probability that an event B will occur given that another event A has already occurred is called conditional probability.
Yeah, you make it fit in that box.
I did make it fit.
Chris, you're having a bad day.
Yeah.
That's okay.
That's fine.
Okay, so conditional probability means, like it says, I'm given a condition. So not just what's the probability of heads or tails, but what's the probability of you being a boy if you're in this class. So there's like an if part or a given part.
So
to
if
it, okay?
Pretty good chance.
Say that again?
So I can live with another
Yeah. So like what's the probability of, I don't know, you being in sports given that you're a guy? You know?
Probably pretty good.
Well, I'm not answering the same. So it's not just what's the probability of being a guy in sports, it's what's the probability of being in sports
within a
if
certain.
yeah. So like you have to meet criteria 1 in order to qualify.
So like we're probably pretty good at like more demonstrators qualifying. You don't know who that is.
In 7th grade math?
Yeah. He threw markers at us. He was angry.
Anywho. Okay. Conditional probability exists when two events are dependent.
So there's.
It does fit. Dependent meaning they rely on each other. Okay?
Do this.
It's okay.
No, it's not. It's wet under my desk and I'm gonna
Ew. Then go justice. Okay. The way that we write our probability, our conditional probability, is probability of something happening given, this little straight up and down line means given something else has already happened. B dash straight dash A.
So this has like a lot of real life applications.
PBA. Yeah.
Okay.
This has a lot of real life applications. And it's just probably.
Yes.
I mean, you want to see the numerals because it kind of sounds more complicated than it probably actually is.
Okay.
That's what Molly did.
Flip this side over, and I want to look at this formula down here.
Yes.
I know, we'll go back. I'm going with the formula first, okay? Okay. Our conditional probability, okay? Probability of event B happening when A has already happened is the probability of both of them happening over the second one alone happening, okay? Kind of, sort of. I know it doesn't make a whole lot of sense yet.
Can you just repeat that again?
Okay, so when we have our conditional probability meaning it has this straight up and down line. How we calculate that is we take the probability of both of them happening, okay, and take it over just the probability of that last one happening. Okay, that's how we calculate it. Yep. No?
How does that work though?
So like, okay, so let's say the probability of you being in sports given that you are a guy, just in this class, okay? So the first one, we would say what's the probability of being in sports and being a male, okay? So males in here, raise your hand if you're in sports. Stop for real, just males. One,
Cam's in a
two,
sport.
three.
Cam and Johnny are in a sport.
I'm not in the sport
Okay,
anymore.
well, if you want to skew it, that's
You're still
fine.
on
Okay,
the team. You're
so there are 4 guys that are in sports, okay? So we would take that over this last one. What's the probability of you being male? Well, how many males are in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So the probability of both of them divided by just the probability of the last one. Okay? Okay, so that's the formula we're going to use for all of these. So flip back to where we were.
Can't write that there.
So, I have students in 2-year colleges, 4-year colleges, and grad school, broken down into male and female. I want to know what the probability is of you being a 4-year college student, given that you're male. Okay, so the first thing we want to find is the probability of both of those happening, being a 4-year and a male, and we're going to divide that by the probability of the back one, the probability of being male. Okay, so far are we okay?
So we're gonna take all the 4-year males and divide it by all the males that are in this like, entire thingy here.
Okay, so to find where our 4-year and males are, our 4 years here, our males are here, so we're this number right here. What is it, 43, 24?
24.
Okay. Does that make sense?
Yeah.
Okay. The probability of being male, you have to take into consideration all of the males. Okay? Yeah. So we add all of these up. Okay? If you don't have a calculator, get one up there, use the phone. 7539, Chloe's got you.
The other one, not me. I'm not that bad.
You're gonna grow up and be super duper charitable one day.
Why do you guys not have calculators? This is math.
I lost mine.
I have a calculator.
Fun to be a jerk.
At least we have them now. Okay, so to find probability, okay, when we talk about probability, I want you to always show the fraction part of it, because that's exact, okay? What I also want you to do is find the percent, okay? So divide these two and multiply by 100 to get the percent.
Ooh, we did this in.
Sure.
57.4.
Okay.
I rounded.
That's what it's
4.
Oops, accidentally divided.
It's 57.4.
So this is really like easy stuff, really.
Yeah.
Wait till she throws the curve.
Yeah, it's short.
You think the boss is easy, but has
Carson,
multiple
I can think
stages.
of my phone
Carson,
out of my pocket.
Molly, stop. Then move back. Okay, this next one. The probability of being a female given that you go to grad school. So the first thing we need to find is the probability of both of them together. So female and grad school over the probability of which one? Being a female or being a grad student?
Oh,
Which one is it?
Over a
Grad
female.
school, because that's the second one.
It's the back one, yep. Probability of going to grad school.
I wrote it wrong.
God, I'm incredible.
Okay. So what is the number that goes with being a female and in grad school?
1954.
1954.
Literally just said-
Okay, now how do I find the probability that you're in grad school?
Add. No.
Yeah, you add all three of them.
No, add the 2.
49.
Add our grad school.
1954.
Yes.
3,303.
3303.
I think so.
I got.
How do I get my percent from there?
I don't know, it might be
Divide and
wrong.
multiply by 100.
Divide, multiply by 100.
This is awkward, Chris.
Come here, come here, come here.
I
Chris.
I got it.
Oh man. Hey Chris, congratulations.
Okay, what did I get when I divide and multiply? Yeah,
59.2.
no.
Yeah, we have to do the.
We got what, 59.2?
Yes.
0.16.
So, 0.2.
Okay. This next one. First off, questions so far?
No, it's making sense.
Continue.
I'm probably gonna be wrong. I'm gonna just leave this one after reset.
Yes, it is. For you.
Okay. Notice in B, it says, what is the probability of being female? What we notice about this one compared to the other ones is we're not given anything, okay? Shh. There's
Wait,
no
So it's out of all
line.
of them.
So it's out of all of them. It's out of our total. Okay. So first off, I gotta find the probability of being female, and then divide it by my total
That's 9,933.
for my females.
Yes.
So all of these is what 9,3.
9933.
9933. Okay, then to find our total, you need to add all of the 6 numbers.
So
Or you can just take the 2 that we already found and add them.
Oh, weird.
That's just because we're trying to find the probability of only one thing, and that's just.
I got
So
When it-
17,472.
Good job on that.
Okay, when I divide them to get a percent, what percent do I get?
56.9%.
What is that?
Okay, I want ears listening. Okay, whenever there is no given part, there's no condition, there's no straight line, it is always divided by your total. Okay? Yes? Okay, so some of those on the homework, and I got a lot of questions. Okay, good on this page?
No.
Great.
You might keep it up for like 2 seconds.
So how do you know what?
What's up, Kim?
Oh, I just wasn't really.
What is that?
What's the other blank that would have?
It's just a bunch of words. It's the probability of event being given.
Is it really important?
Chris, we good?
What is it, 9733?
9933.
9933?
And that's just the total of our females.
Okay.
Okay. Alright. Okay, this time we gotta figure out what our conditional probability is. Okay? So, read our paragraph. It says we got the thing about waste. I want to know what is the probability that a sample of recycled waste is plastic. Okay? So the first condition is that it has to be recycled. Okay, so that's our given part. That's the back part. Okay, the other condition is that it has to be plastic. Okay, so our probability is that it is plastic given that it's recycled. Okay, the order matters. Okay, because if I've flipped them, the first number will be the same, but what you're dividing by on the bottom will be different. Okay?
So do you switch them around always? Because it says the probability. Oh wait. The probability.
That a sample of recycled waste is plastic. So if it said, what's the probability that a sample is plastic or that's recycled or something, then you would flip them. Yes.
How did you figure out the recyclables again?
Because it says that's the first thing that shows up.
If
It says it has to be recycled first, and then if it's recycled, what's the chance that it's plastic?
So if it's a sentence set up like that, you always switch it.
Yeah.
If it's set up.
So it's out of everything that was recycled.
Right.
So that would mean the probability
Hold on,
would be.
hold on. Okay, so up top is our combo. The probability that it's plastic and recycled. And how much is that?
Plastic and recycled 2.1.
2.1. Okay. What I'm dividing on bottom, is that the probability that it's plastic or the probability that it's recycled? Recycled. So Deshaun says I have to add up all my recycled. And how much was that, bud?
79.4.
79.4.
Yep.
Okay, if I divide and multiply,
Your probability would be 2.6.
2.6%. Good.
Wow.
Very good percentage.
Which is crazy because you'd think that
Yeah, a lot of stuff
more
gets recycled.
recycled stuff would be plastic. But most of it is paper and other. I don't know what other is. I suppose like recycle wood.
Recycle wood.
I was gonna say like.
I accidentally cut down too many trees.
Recycle.
Yeah.
You can recycle wood, carpenters do it all the time.
Thank you, so I'm not crazy.
Sorry,
Okay.
I'm not a user.
Probability. The sample of non-recycled waste, so that's my first condition, is paper. Okay? So I have to be non-recycled first, so that goes in back. Okay? So I need to be paper and then non-recycled.
Not sure.
Okay? So how do I find what number goes on top? It
That
has
would
to be what and what?
non-recycled and whole paper and then non-recycled.
Paper and non-recycled. So we're at 37.8. What goes on my bottom?
All the non-recycled materials.
All the non-recycled.
No.
So I total them.
Oh, we don't
And so that would be 136.7.
Are you sure?
Yes.
I'll double check. Yep, that's right.
Is this gonna lead into the other chapter somehow, or is it just this its own
This is
thing?
kind of just the stuff.
Are we doing
Score.
probs and algebra?
This is really all we do for problem states.
And then your probability would be 27.5.
Ooh, I got 0.7, so I gotta go with Chloe.
Yeah, I got that too.
I got that
You
too.
didn't even calculate it, don't even mind.
Oh,
For
yeah.
real?
Getting calculates.
That's what I thought.
She did.
Oh yeah, it did. Yeah, we are.
You got a hole here. Okay.
I got a what?
Hole
No,
in
because
the
it's
hole.
an oval.
Oh, yeah.
You are walking a tar
I gotta ask, whose funeral are you going to do?
It's squad day, and this is probably the only thing that all besides
That's like God.
Okay, last page. Okay. This last page is kind of an explanation, longer, of how this all works, kind of, sort of.
Is this gonna make sense to us? Like, make it.
Well, you're gonna be like, thank goodness you didn't start with this.
No, chill.
Oh, yeah.
Oh,
This
this
is-
is awesome.
That's not something that makes
That's
me
why I
happy.
go over.
Was it you who called it?
Apply shampoo.
I know. Don't ask where this stuff comes
You're
from.
who called it first?
Okay. Okay. One thing that I'm going to recommend when it comes to homework and stuff, something that I like to do is before I even read, I just find totals, because then I just feel like it goes faster, okay? So if I find the total of male, what's the total of male?
And 20.
20,
The total of female?
30.
So how many people total are there?
58.
Okay.
See, I like that math. Can we do that math? Yeah, do this. Let's go back to this.
What's the total of people that apply shampoo directly onto their head?
What is this?
And what is the total of people that put it in their hand first?
Me.
Who puts it on top of their head?
Don't ask
You
where
don't-
this is.
I've had
What
it
is
Like, what happened for it? Like,
No, because mine has the little pumping.
I always
so
put
I
my
do this.
shampoo in my
See, mine's so up high, I can just like.
Okay. Yes, I know it's crazy. I know.
that's like
Yeah.
melt it before you put in the cereal.
They want
No,
you to toss
it
it
is
in.
better take like bags. Kidding.
Wow, where do you go?
Can we
do
our own
it?
version
Well, we're
of
pretty
this?
No way.
Yes.
Can we do our own version of this? Like,
No.
I thought you were saying yes to a
No.
barn thing.
Okay. So remind me again what we do if there's no vertical bar.
Total.
Divide by total. What's my total?
30. 30. What?
50.
50.
Just stop at 50.
15.
Wait, what?
Okay. I want to know the probability of being female and directly applying shampoo to my head.
24. 24 is the top. 6 is the top.
30. 30.
So you're telling me 30 females directly apply shampoo to their head?
No.
No.
6
Over.
is there what over what?
30.
30.
Over
No.
8.
Oh, 8. I'm over.
This is
6 over 8.
confusing.
No,
than the
yeah,
other
no,
one.
it's 30. Yeah,
Six.
6 over 30.
It's
30. 30.
It's 30.
Is there a bar here?
Is it 30?
No.
So 50.
So 50.
What?
Wow.
When there's no bar,
Everyone
Always.
sit down.
your total.
Everybody's mind.
No,
I don't think you can even
where?
say directly opposite.
So like here there's a bar,
Yes.
here there's no bar, here there's no bar.
Okay, I get it.
Okay.
I like made a little
That
note.
shit.
Okay.
Yeah.
I got it.
Whenever there's no bar,
You do the
no conditional, you do all total. Okay? Okay.
I got it.
This question, which way is it? Do I do both of them, the directly and the female on top or bottom? So which one is correct, left or right?
So you put the bottom one is the right.
Right.
We do both of them on top, divide by the bottom on, or divide by the back on the bottom. Okay, so what, holy, too far. Okay, so what number 18 is telling us to do is use the stuff we did in 16 and put it in for our probability here.
Okay.
Okay, so the probability that females apply it directly to their head is this whole 6/50. Okay, and I have to divide that
Holy,
by the probability of it being female, which is 30/50. Okay, third hour, I want to just put them in decimals. You guys want to do that?
Yeah.
Okay, what's 6 divided by 50? 0.12, and what is 30 divided by 50? 0.6?
0.6. You're right.
Yeah.
So what is 0.12 divided by 0.6?
It's over 1.
0.2, I mean 0.02. Right?
2.0.
What?
No.
20.
No?
100.
Why?
Isn't it?
0.2,
Is it
0.2.
2% or
It's
20?
0.2.
Yeah,
0.2.
0.2, so times 100 would be 20.
Yes.
Yeah.
Okay.
Okay,
Yeah.
so this formula that we've been using back in the other ones, what we would have normally done is taken this number, the female indirectly, which is just the 6, and divided it by just the female, which is 30. Do I get the same answer?
Yeah.
Yeah. Which is why we don't divide by the total, just do it this way. Does that make sense?
So then when I
Cause-
was saying 6 out of 30, I was actually right.
For a whole answer, yeah. Not for the female and direct. Okay, last one.
I was also. What?
Is it time to go?
No.
Is it? Can
I said I was also right.
Oh, okay. Alright, let's do totals first.
20.
What's the total of our males?
30.
20, 30.
50.
Total of our online is how much?
I believe said 50.
I was talking about the end.
Oh, this total, 50. Okay, gotcha. What's the total of our online? 36. And the total of our male? 14. Okay, so I want to know what's the probability that a customer pays the bill online given that they're male? Okay, I think the hardest part is trying to figure out which one goes first.
No, male. Correct.
Okay, so I know I'm going to have probability. Well, it says what's the probability that they pay their bill online given that they're male?
So male is going
So
second.
P,
Right.
male,
First.
line, online, parentheses.
Yeah.
No.
What she said. It's a given.
Female.
Given.
So male is
Given
in the back.
goes in back.
So
Given,
male's
what are we
in the
given?
back.
Yeah.
We're giving
The
the
males
the
in the
males
back.
in the back. We're giving the male.
And so then online has to go in front. Okay, so what's the probability? Well, you tell me what goes on top.
12
Probability of what
males that pay online.
males that pay online, which is
12.
12
Over total.
over what, Chris?
20.
Total males, which is 20.
Look at my calculator.
And what do I get for percent?
60%.
Is it? Okay. Questions?
No.
Yes, we are.